10.5, the distance formula. Sorry about this little area here. That should also say the distance formula. And this is all dependent on understanding the Pythagorean theorem. So that's where this comes from. So before we talk about the equation and all that kind of stuff, let's sketch a little bit of a graph here. And I'm going to only worry about my positive axes. And over here, if I have a point and another one, then I can figure out the distance between these 2 points. So I'll label that as D. And what this means is that my first point has some sort of x-coordinate and some sort of y-coordinate, as well as my other point. But it's not like I can use the same x and the same y. So the common way of writing this is having a little subscript number below each, so that I have x sub 1 and y sub 1. So I'm saying SUB, they're sub. And then I have x sub 2, y sub 2. This has nothing to do with exponents, all to do with telling the two of them apart. So I call the first one x sub 1 and the second one y sub 1. Now, I'm not going to connect this and form some sort of strange-looking triangle. I have to draw a right triangle, and so I'm picturing a right angle down there. So this is going to drop down and come over to the right, moving straight down, straight over to the right, to form a right triangle down there. And what I end up having is a right triangle where D is the hypotenuse. So, going based on this, if I had to label this point, its x-coordinate would be x2, because that's at the same location in terms of x. Its y-coordinate would be y1. But the whole deal here is that I can find the difference between these two locations to where this side would be the difference in one of the x's from the other one, and then this would be the distance between the highest most y and the other y. So I'm labeling this, and I did use red there, but I think a good sketch will help you see this. And what this tells me is that if I treat these like they are the legs of a right triangle, then I can square these differences, add them together, and it'll be the square of this. So we'll go through this in greater detail if we haven't already. But for now, we're going to jump into D is equal to the square root of x sub 2 minus x sub 1, so that's the difference of the 2 points, squared, plus y sub 2 minus y sub 1 squared. And then I'll extend my square root to make that look nice. And I wanted you to rewrite that larger so you get your own practice. So find the distance between the 2 points at 2, 3, and negative 4, 6. If I'm doing these problems, then I'm going to list these coordinates so that I have a way to track my work. I'm going to have you do this the first time. So let's go ahead and think of this as being our first coordinate. So above this we'll write x sub 1, comma, y sub 1. And the reason they're both 1 is it's just saying that this is the first xy coordinate we're going to deal with, which is going to make it different from x sub 2, y sub 2. So just tracking purposes as we do this first one. Rewrite the distance formula. D equals the square root of x2 minus x sub 1, close those parentheses and square that, and then add on y sub 2 minus y sub 1, and then we'll square that as well. Now, the D is implied, so here we're just going to rewrite equals. We're just going to rewrite that, and then open up a big square root. And for x sub 2, my eyes go here, so I'm going to write negative 4 minus x sub 1, which is 2. Close those parentheses, And I don't have to worry about minus and negative or anything there just because of the way the numbers worked out. And then I'll add y sub 2, which is 6, minus y sub 1, which is 3. And then we'll close those parentheses and square it. Now, I'm not going to skip a line because you should. I'm going to skip a line because I don't really have any room. So I'm going to open up the radical again. Negative 4 minus 2 becomes negative 6. But I'm not going to just write these squared. I have to write that in parentheses. And then I'm going to add 6 minus 3 to be 3. Just for the heck of it, I'll keep that in parentheses as well. Negative 6 squared becomes 36. Plus 9 becomes the square root of 45. And then pulling from the previous chapter, we know that 9 fits in there, so I'll write 3 square root of 5. If you're not sure how I got there, pause this and find me or star it. Now, all of this work on its way down could be avoided by just typing this into the calculator. I want to see all this work because it's going to help you for problems where the calculator can't really just take it over for you. Also, this can be approximated, so this would be approximately 6.7, but for our work and our purposes, I'd like to leave that exact so that we can keep the equal sign. And go ahead and, since you have a laptop open, go to Wolfram Alpha and type distance, and then just type this in. So if you type distance and then open up parentheses, you'll end up being able to check these pretty nicely in Wolfram Alpha. Moving on to the next one. It has no importance to these problems, the order in which you do. Like you could make this x sub 2 and that x sub 1. It really doesn't matter because with the distance and then with squaring something, it's going to make that a positive result. So that won't affect how we do these. So now I'm going to rewrite these again. 4, negative 1, comma, negative 2, negative 5. And again, I'm going to label these, but I'm going to label them in red so that you know this is optional. So I get x sub 1, y sub 1. And if you're not sure to make it optional or not, then you should always err on the side of caution and label this anyway. What is not going to be optional is rewriting the distance formula. Rewriting the distance formula is going to get you closer and closer to locking this in. Okay, so I got the square root of x2 minus x1, and so on. I'll bring the equal sign down, get crazy large bracket. I'm not trying to take up multiple sheets of paper here. I'm just trying to make my writing neater. So here I have, in parentheses, negative 2 minus 4, and I'm going to square that. And then I'll add on negative 5, and this is what I was talking about. It's going to be minus a negative 1. And then I'll close these parentheses and square that. And the reason I point that out is just as you think of negative 5 minus 1, when we come back and do that, it's really negative 5 plus 1. So that will be probably your most likely point to make a mistake. So I get negative 6 squared again, plus, and here I have negative 5 plus 1 becomes negative 4 squared. And you're going to be tempted to cut a lot of corners here. I'd rather you not. 36 plus 16 ends up giving me the square root of 52. And since 4 fits in there, I can pull 2 out, and it'll leave me with 2 radical 13. And I'll box that. Now, if you still have that Wolfram Alpha tab, you can just jump, reopen what your previous entry was, and then just go back and, replace the coordinates as a nice way to check these.